Good evening, everyone. It is indeed a pleasure to welcome you all to this panel discussion on opportunities in mathematics, India and abroad. So, why should we discuss about the career opportunities in mathematics? Why is mathematics different in the modern day? So, I would like to read out a few points which I have prepared. So new application areas are constantly being discovered, while established techniques are being applied in new ways and in emerging fields. Consequently, a wide variety of career opportunities are open to people with mathematical talent and training. The very idea of career in mathematics has evolved and diversified and is often coupled with a specialty or an area of research interest. Mathematics plays a major role in the bottom line of industrial organizations and helps companies perform better in today's data-driven marketplace. While career in mathematics may differ widely by discipline and job title, the one thing which unites the different areas is the ability to do problem solving. Some of the potential problems a mathematician can address in the present world can contain the following. Can an airline do a smart scheduling of its air traffic to reduce the cost of airline parking and engine maintenance? Or can they come up with smarter pricing to maximize the profit? Is it possible to design a clinical trial in an efficient way? And building such a trial will require advanced statistical tools and sophisticated knowledge of the design of experiments. So is it possible to use the modern computing power available to predict the interaction of the ocean, the environment and living ecosystem to model this atmosphere in a very efficient way? Now, how pandemics and diseases spread in populated areas and how is it possible to contain them? Now, can you come up with efficient strategies of investment in various financial instruments to meet a risk. So these are some of the questions which are definitely non-conventional and which a mathematician can address in the present world. Now, to dive into such active areas of research and applications, it is essential to have an idea of the state of the art research and the various areas of application of mathematics. So we have got an eminent panel of mathematicians from the School of Mathematics, my colleagues, Dr. Sridharan, Dr. Sheetal Dharmatti, Dr. Nagaiah Chamakuri, and Dr. Viji Thomas. And each speaker will speak for about 8 minutes on some topics, and that will be followed by a Q&A session, and we will end with conclusion. And I would like to appreciate the CMIT for taking this initiative. CMIT, as you all know better than me, is the official math club of IISER TVM, which is working in association with the School of Mathematics, and they organize regularly seminars with students and faculties. They have panel discussions, interactive sessions. They have training for various national level entrance exams and so on. So with this, now I pass on to the panel members, and we will listen to Dr. Shrihari. Please.
Thank you. Do you guys mind if I stand? I will not be able to speak when I'm seated. On different occasions, I prefer to sit and lecture. On a different occasion, I'd like to stand and lecture. Okay. First of all, thanks to the organizers for inviting me here. Thanks to the moderator who called us eminent people. When I was approached, the title that was going the rounds was Challenges and Opportunities for Mathematicians, or for in the field of mathematics in India and abroad. But eventually I believe that the challenges have been dropped. We seem to have overcome those challenges. Therefore, we will only speak of opportunities as of now. Now, as my colleague Arun said, there are very many frontier areas that are opening up in applications of mathematics, wherein you study a mathematical model to understand how things will be, or how you want to forecast a particular weather, or these are all pretty old themes of weather forecasts and stuff like that. I'm from a different era probably, and therefore I should still get modern with these kind of things. But of course, he also spoke about the modeling of the pandemic and the way of foreseeing the next wave, if there will be one, and how to curtail it before it kind of affects us, etc., etc. But I sincerely believe that one needs to know the theoretical framework of mathematics to be able to apply all these things as they come along. Now, it is quite different to actually, take a problem, solve a problem, and say, hey, you know what, I have solved this problem, which is quite good. I'm not in any sense diminishing that or reducing that in any way, which is quite good. But the problem is, given a different set of parameters which may come at any point of time from now on, are we well equipped to tackle those problems as well? So that is something that we all need to worry about as well, and therefore in that fashion, I think concentrating on the theoretical aspects of whatever we have is also essential. Now, I was in particular written to speak of my experience in Europe, application for PhDs and postdocs, work experience in India and abroad, etc., etc. Okay. Now, this is a very heterogeneous audience, and therefore I'm pretty sure there will be different sets of people who are interested in knowing different kinds of ways in how how you go about this. And as my colleagues will also tell you later on, there is absolutely no single way to kind of do this. There are multiple ways in which you approach these problems. I mean, if you're interested in, first of all, that's a very, very essential qualification. If you're interested in mathematics, only then you can kind of do something. There are times when we think we are interested in mathematics, but then your interest in mathematics is something that you should be able to actually understand by taking a problem that is left in the exercises of your textbook, sitting down with a notebook, dirtying the paper with ink, and being able to achieve what the problem asks you to do. Most of us, even now, listen to lectures with a with a palm on your chin, as though there is some concept that is going on. Most of us, even now, after everything is over, kind of read through certain, 3 or 4 pages and say, I've understood things. And that is exactly not how you do mathematics. You think you have understood it only when you will be able to write it out in your own words without looking at what has been given to you. When you can do that, then you're interested in mathematics. An interest in mathematics is absolutely necessary for you to kind of get into this stream. It's difficult for you without it. There are several people who think they are interested in mathematics, land up here, and then somehow fall out midway. So make your choice. There are people who started with a non-math background, nevertheless have ended up in mathematics. I mean, all these things happen. It's not that this is the right way to go about it or this is a wrong way to go about it. There are umpteen number of universities in Europe. In fact, from my time onwards to now, when I say my time onwards, I'm talking of the time when I was applying for PhD positions, etc. From that time onwards, until now, I'm not telling you when this was, just in case. But then, things have vastly improved. You can get details at the hit of a button. You guys know that much better than I do. There are several scholarships that have come about in today's world. The earlier existing scholarships also prevail. Your EPSRC fellowship is something that that could be valid in European Union. There is this DAAD fellowship, the DAD fellowship that's valid in Germany. All these things ask you for something, which is how well you have performed in your current place. So that's something that you need to kind of focus on. And have this, thirst for actually doing things in a fashion that if a new parameter is introduced in your problem suddenly, even as you go by, that you will be able to tackle it. So that's a very important aspect of mathematics. And I don't know. If I need to speak on any particular thing, then maybe ask me during the question session. Then I'm not sure what else should I cover now. Did I answer anything pertinent, or did I just was I just rambling through? Sure. So I'll stop here. But maybe I'll answer your questions when we come to it again. Is that fine? Thank you very much.
Now we'll listen to Dr. Sheetal Dharmatti.
So, you are able to hear me?
Yes.
So my microphone. Yeah, it's on. It's on.
Because you should be able to do.
Okay, so yes, so I should congratulate you or whoever has designed the questions. So it is very nice nice thought that you have given different. You want to know the different perspective about career, whatever you want to do in mathematics, right? Careers in mathematics, and I should. So it's very clear that whoever is here is really interested in doing career in mathematics. This is what my assumption is looking at the email. Okay, so congratulations for that, and thanks for giving this opportunity to be here. Okay, so let me just concentrate on the questions which were given to me. But I will go to the third question. I am not going to follow the order. The third question was your advice for the students in taking up mathematics as a career. A single line advise it, get into it only if you are interested in mathematics. Okay, so that is the, and I don't think I am capable enough to give you any more advice than this. So first thing is, to do career in mathematics, you have to be interested in mathematics. And by now you all have got some hands-on experience with the mathematics at a higher level, not just at the school level where you had given some problems, you were told a technique and you were solving it. So mathematics is much more than that. All of you are know, we try to prove theorems, we try to do so many other things, but all that is to understand the bigger system, understand the generalized concept, as Shrihari was mentioning, to even if the parameters are changed, how will you look at it? So that is a more generalized aspect of mathematics, is what will be more important when you are doing the higher studies, and hence unless you are interested in it, you will not be able to do. As far as the applications go, like what Arun was mentioning, yes, there are hundreds of applications where mathematics is useful, and hence there is no dearth of career options in mathematics. So even in India or abroad, according to me. But obviously the kind of mathematics which we learn at a higher education level is not sufficient to cater to the industry needs. Okay? So that is why one needs to actually augment your knowledge with some other skills. You have to have some computational skills, some other kind of skills to actually find a career opportunities in other than academics, right? So when I say that there are no dearth of jobs, I mean other than academics. Now coming back to so this was your first question about the academics. Yes, there is lot of pressure, lot of things are changing. Yes, there are many more institutes coming up in India. So the need for, the job opportunities in academics, yes, they are increasing. But at the same time, you will see, like from yourself, there are 7 IISERs now. From each IISER, 20 students coming out every year, right? So do you really have so many opportunities in academics? So one has to think about that. Okay? So if you want to be in academics, you have to be really good. You have to have a balance of theory as well as applications. That is what is the need of the time. But as I said, in industry there are lots of opportunities, and you people should try learning different skills. As I said, it is not necessary. See, mathematics as a whole, if you are doing your courses very well, whatever you are learning with this thing, I think it gives you logical thinking, reasoning, and these are the 2 things which you will require in any other skill which you want to have. Correct? So both these things you are already getting. So your whatever journey here is not going to go waste at all. That is for sure. Okay. So, but then if you really want industry opportunities, yes, you need some more skills. And as far as the opportunities, you have also asked me to talk about the placement opportunities in IISER. So as far as I know, yes, math students through IISER placement cell have got jobs provided they have some computational skills. So this is what the data says currently. Okay, I'm not saying that is the only thing, but I also know there are IISER students who have graduated, who have gone to the academics, either PhD students or even MSc students. They have been doing jobs, various jobs, and there are students who are working in various other fields like science education, science communication. So for all those things also, this knowledge of mathematics helps, because more and more systems are dependent on mathematics. Whether it is biological system or chemical systems, everybody wants to model them and predict, because that is much easier than actually doing the experiments. That is a very costly affair, whereas having a computer and trying to model it and doing it is far easier. That's what people's perception is currently, and hence mathematics will have more and more applications. I mean, people will find, and you will also be able to find if you correctly look at that. So in that sense, IISER TVM, I think we have had some placements. I will not say that it is 100% or anything. I mean, all of you know about that. But yes, if you have some skills and there are more companies are coming up in IISER, if you are aware of some companies, you can also inform the IISER's placement cell, and they can actually invite. The biggest challenge, as I understand, talking to these people in the placement cell, is most of the companies demand that your CGPA should be above 8. And it is very disheartening, I know that in maths department, it's not very commonly found fact, right? I see that in biology and chemistry, because I had seen the data. In biology and chemistry, this is very common. Probably some onus lies onto us as well, but surely there is onus onto you to improve your grades. So that is also one thing I would like to add. Okay. Yeah. So more things I would say in the question answer session if there are any. Thank you.
Thank you, Sheetal. Now, can I request Dr. Nagaiah Chamakuri to address?
Okay. Thanks, Arun and the CMIT for organizing such nice event. Well, I will speak only the questions. Okay. So apart from that, already, so my colleague said, well said. So the opportunities in academics also I will not touch. Already the Sheetal mentioned. Okay, I'll go through the questions now, just see, so what is the experience in Europe, what is my experience? So because I did masters from IIT Madras, and then immediately the next day I landed in Germany. The first day itself I got my office, my computer, everything. Even the problem what I'm going to do as is given. But they did not say how to do, what to do, right? So this is the project, because in most of the abroad, all the PhDs, so there the funding is not provided from the government. The professor has to write the grant and get the grant. Okay, so it is not like in India we are giving like thousands of CSR fellowships and we just join the PhD and we just do it for relax for 5 years. There is no. The project is run for 3 years or 4 years, and you have to finish everything within the time period. So the pressure is there. So that's what is given. So it was reasonably good, and I don't know. So you have to tell about the experience in India. I don't have that. And advice for applications for PhDs and postdocs. So when you are BSMS students, so I would suggest that you should do a very good project in your major project. At least if you do it, if you have some kind of some work which can really reflect what you are trying to, what you are going to choose the research topic, that really helps. Suppose for instance, if you do some pure mathematics, and then if you look for the application, the project in the same area, definitely you are the right candidate. And if you are doing some applied mathematics in some application, and if you apply for that position, you are the best candidate, definitely. So for the postdocs, well, that depends on your publication list, right? You should have a good publication, not the number, but the good publication. If you have 20 publications with unknown journals, no one cares. But you have like a 1 or 2 science journals or something that really values, and definitely you will get the postdoc. And yeah, the work experience in India and abroad, yeah, it varies, right? There are no disturbance in abroad. You just go to office at 9 o'clock and leave at 5:30. That's the work culture there. And in between, so we don't go for chai, tea or something, chatting, there's nothing. But here we do a lot of things. That's the reason the working hours also increased here, right? We go around at 9 and we leave office at around 6 or 6:30. But the work culture is really nice there, so that we should bring here as well. We already have, but try to that one. The commercial values of degrees in mathematics, yes. So the mathematics degree is valuable actually. If you really look at it in all the applications, all the subjects, you can do mathematics in every subject. If you go, suppose any experimentalist, he is only fit for that kind of experiments, and he is fit for that kind of industry as well. But for mathematics, the advantage of mathematics has argument, like if you add on top of that, you have a basic degree in mathematics. Suppose if you add some programming, you can go to IT. If you add something on the simulation for, so as Dr. Arun said, there are a lot of industries where you can look at the aerospace industry or automobile industry or healthcare sector. There are a lot of opportunities for mathematics. But the same candidate, if you, those who are really doing the experiments, you cannot find such kind of job market. But for mathematics, really, really vast. So if you really pitch in, look at what is in this, nowadays the buzzword is machine learning, artificial intelligence, right? What is there inside? Probability and optimization. Linear algebra. So if you know these three, you are the master. You can apply for any industry where you can see data analytics, the big data, whatever the weather prediction, anything, any risk management, or anything. And the last one is, so your advice for the students in taking up the mathematics as a career. So as I said, mathematics is everywhere, not like the other subjects. So I already mentioned, if you are passionate about mathematics, yes, choose the mathematics. If you are really passionate about IT, just learn on top of mathematics, just learn some programming, you are the best fit in IT. You will do the much better because you have a lot of logic, the analytical thinking, compared to the other engineers or the scientists. So that's what, thanks. If you have any questions, I will answer.
Thank you, Nagaiah. Now, may I request Dr. Viji Thomas to give his address.
Hello everyone. Actually, I missed that I had some points that I had to speak upon. I just realized that points were also sent. So in panic, I opened up some things that I had looked up earlier in my life, and I have it. So before I go to the points that I'm supposed to speak on, I will say, initially when you said opportunities in mathematics, I wanted to make you all aware that there is a book called Case Against Education. This means, is education needed at all? The book makes a point. You can go and look at the book. It suggests something else. So I was just going to say, you should not say opportunities in mathematics. I will make a case that there are more opportunities in mathematics than others, but there is a book like that that says Case Against Education. And it makes a nice point. It is tedious, but it is essential. Yeah. So second thing I want to say is about, see, there are people, economists, who go around and see what mathematical knowledge is required for what particular job. That is their job. I mean, these economists go and look at this. So, and this is, you can read about this. There is a book by Sherman Stein that says Strength in Numbers, and then there is, the title goes on, and you can read about how, what, and everyday aspect of mathematics, how mathematics can help you. Last, about opportunities in mathematics, and I will come back to what I am supposed to speak on. This I think I can speak easily. I was initially worried that the points would be something difficult, and this. So let me, so after reading this, you will see, this is, I'm going to, I read this a while ago, but I remembered and I quickly opened it because I wanted to at least say something about opportunities in mathematics. So it is about mathematics, why it is important. So it is, it's a quote by Conrad Hilton. It is the founder of the Hilton Group. He says, I'm not out to convince anyone that calculus or even algebra and geometry are necessities to the hotel business. But I will argue long and loud that they are not useless ornaments pinned onto an average man's education. For me, at any rate, the ability to formulate quickly, to resolve any problem into its simplest, clearest form has been exceedingly useful. It is true that you don't use algebraic formulae, but I found higher mathematics the best possible exercise for developing the mental muscles necessary to this process. So this is what captures everything about mathematics. It's the process that goes through. And now let me quickly come to the thing about use of mathematics or where you are getting, I mean, how jobs. Now, if you go to a Wall Street interview, most of the, and there are books that prepare you for Wall Street interview, okay? And most of the problems that you see will be mathematical problems. So even though these jobs may not require your mathematical ability, what they test you on is some mathematical ability. You may not require the mathematics in the job, you may not. Perhaps you don't require most of the things you learn in school in any of your jobs. But when it comes to this high-powered interviews, in some of these high-powered jobs, what is required, the books that prepare you, if you go and look at these books, then you see that it is mathematical questions, probabilities, statistics, linear algebra, very simple questions, but you would require some mathematical knowledge. Second thing I want to point out is when I graduated, many of my we were about 15-20 students, 5 or 6 didn't finish PhD. They decided that they will go into IT industry, and they were just welcome because they had almost got the PhD. Thesis was not written. They were said, okay, enough. Job market is difficult in US, so we will just go ahead. And so they were just offered the job directly. Now they are earning much more than a distinguished professor at any of the universities. So the point is, if you have a mathematical PhD, many of these companies just invite you. I will tell you, I don't have anything, I don't know anything about computers, but at some point I had some family problem and I wanted to go to US for a year. I had a standing offer that you can come, you learn whatever Python, whatever you have to learn, we will give you 3 months, you learn it, and you just join. It was a kind of just an offer. So nothing, but I was not confident, I was very scared to even just look at computers. So I didn't take up this offer. But the point is, if you have a degree in mathematics, this is highly valuable compared to anything else. That is my bit about mathematics. Also, there is this, in computer science, they have this coding contest. In any of this coding contest, if you want to go, what happens is many of the problems are mathematical in nature. You of course need some computer science background, but many of this is like that. Now I come back to my questions. My experiences, I think the first questions, your experience in US, advice for application for PhD and postdocs. My experience in US was fantastic. The work culture is slightly different. Here it is more, in some sense, more better because you do not have to teach a course, you do not have to grade. So there we have to teach our own course. It's not like a tutor for a class. We have to teach our own class and we have to give exams and grade. So there is a lot of time is taken. Of course, what you get back is free education. Here you do have free education, you are also paid, but you do not have to have your own class and grade and give assignments. So you have more time. So it gives you more. So in that sense, you have much more time and much more chances of doing much better than suppose a student who goes in US, if you put the mind and the time. Application for PhD, well, it all depends on how interested you were, how well you did, and then I would suggest application, especially for US, that you have to send out at least 5 applications, and better if you send out 10 different applications. It is costly, but I would suggest you do, in which you aim 3 high, say 4 or 5 at an average level where you believe that you can easily get into, and you will get into one of these places. One of the important facts there is not about whether you had a paper or something like that. Of course, most people at master's level will not have a paper. What is important is how much mathematics have you read. So for example, if you can say this out, if somebody, you may say whatever you want, but somebody, one of your professors should say that, yeah, this boy has read this much he knows this things. And if you are sincere and somebody writes that for you, this is what counts a lot, and then they are confident that perhaps this boy or girl might be successful in our program. He has this, he has the required, there is a chance that the person can succeed. So if you demonstrate that you have, don't just go about reading your just the courses, try to read as much as possible. This improves the chances of getting admissions for PhD in US. The system in US is not like grant writing, and then as I said in Europe, it is just more or less similar to India. The department is what gives your fellowship. The department pays for you. It's not the individual. Individuals also have, but department has a fixed number of applications and that they can support, and it works that way. I will just quickly, I think I have exceeded my time, but let me, where is this now? What was my, I had some other things that I had to say. Yeah, so your advice for students, I will go to the last question directly. Your advice for students taking up mathematics as a career, if you like mathematics, just go ahead. I mean, it is something that you can do with complete passion. At some point, I thought that this is the only thing I can do. And similarly, there is nothing else I want to do. I mean, this is the only thing I think I can at the moment think of doing. Similarly, you should also, hopefully by the end of 5 years, the clarity will be there whether you want to continue. If you think that, okay, this is enough for me, there is nothing wrong in it. There are other opportunities and you can take up those. But if you feel that, yeah, this is something I'm enjoying, then don't worry and listen to others. Hey, this is difficult. There are plenty of opportunities. There are so many universities, so many IISERs, so many IITs, many positions are open. If you do well and you are sincere enough, I'm sure you will do well, and there will be opportunities and there are chances. So I think I will end
So let's give a big round of applause to all of our panelists. Now the floor is open to your questions. So you can start.
Sir, suppose a person is like good at computations, specifically natural language processing and computer. Okay, that person is me.
Okay.
So, and this like CGPA is not very terrific. That's not fantastic. Suppose how will that affect his career or business? He's interested into like research and like industry.
No, so I lost the first line, I'm sorry, but can you, what was the first?
So his things, he says the person is really good in computation, but his CGPA may not be great, really, but so.
Anybody want to answer?
I can answer.
I can also answer.
Yeah, you answer.
No, you go.
No,
No, he asked everybody.
Yeah, so
Yeah.
let's see.
Yeah, so
Sheetal,
I think it's only the entry point in the, I mean, if you are looking at the industry point of view, it's only the entry point which is a problem, because later on they are not going to evaluate you. So what I spoke about is getting a job through IISER careers and IISER placements. But of course you can have outside connections, and through that you can get it, and people have got it. So you should not worry about it. But you should also, as Nagaiah was mentioning, you should also have some demonstration about your abilities. Because that's what industry needs. Industry is not worried about what marks you got in your 10th standard or at MSc. No, nothing. They are not interested in that at all such things. Okay, so it's only the entry point is what is the question. Otherwise, it's not a problem.
Yeah, but it's not like purely job interested, like some research also. It's like job come research. Need money and like passion.
No, I mean, to answer that, so for your information, every industry has a R&D department.
Yes.
Suppose if you take aerospace, without R&D, they cannot run anything. For instance, if you take any automobile, right, developing the car, You are seeing that the car on the road releasing in 1 month. But do you know how many cars they will destroy before releasing it? The car crashing test? Like 10 years back, it was around 200 to 300 cars they destroyed. Because they have to test the crashing test for every corner. So what happens if 2 cars met an accident? So what happens to the driver, what happens to the passengers and everything? But nowadays, because of the computing power increased, so they really create a virtual vehicles and they do the virtual testing, and they do, even the government also accept that. So they do all the things. And if you remember this Volkswagen scandal, like there's a pollution test, right? But they do it in a computer. So likewise, every industry has a R&D department. It is not like they're just writing some coding and doing it. No. That's what I said. Mathematics is really, really challenging. And if you're really good in understanding the mathematics, how you transform your mathematical skills to the computing, you are the best.
It's like
Among all.
applied mathematics.
Yeah.
Yeah. You should have a logic. You should have analytical thinking. Suppose for instance if some simulation fails, then what do you do? That's what you apply your theory, right? So why it fails? There you are going to use your analytical thinking.
Yeah.
Viji, you want to answer?
No, so if you were planning to go into, say, still research and you were not doing well in your courses, I am sure at some level somebody has to see your talent among your faculty, among your professors. And you have to catch that faculty who thinks that you are good. Whether you are good or not, that is different. But at least you have to catch the person who thinks you are good. And then that person will vouch for you, saying that, okay, this the CGPA, everything looks not so good, but he is very good in so and so, and he or she may suggest, maybe you go into this, and still it works. It is not necessary that, yeah, of course, if you don't know anybody at a university, then they will look at the thing. But if your professor knows somebody at some place, and you have impressed or you made sure that you have demonstrated your skill, and one of the faculties knows about it, that, oh no, this person is actually good in this, other things is bad, then but still he will say, oh no, there is something here, please consider, and this will be taken into account. So it's not always that your marks go, it's not always like this.
The CGPA is not the
Yeah,
last word.
like for example, let me tell a story of one thing that was told to me. So maybe this name will be known to Shrihari. So there is a very good researcher in dynamical systems called Robert Devaney. Now Robert Devaney, as far as I remember, was a student at Berkeley. And his Susan, I forget the teacher's name. So as an undergraduate, some problems were given, he would not show up, but the teacher knew that this guy is somehow smart, so just passed him in the course. Finally, now, because his GPA perhaps was not good in that course at least, but I know for sure that later in life he went on to collaborate with this person, and the same person, Robert Devaney, is a very famous dynamical system. I know at least one book by him. There are several books, but Robert Devaney has several books. So he perhaps didn't do very well in his as an undergraduate student, but somebody saw somewhere that, oh, this person is. Of course, if it so happens that nobody sees that you are good and you are actually good, then I don't know what to say, but somebody will see it. Yeah.
Probably I will like to add to this. As far as these PhD applications go, many of the European universities, like Nagaiah was mentioning, they already have a project. You already know what you're going to work on. So they rely mostly on the recommendations than what is written on your transcripts. Whereas it's not the same case in the US, because they are supporting you from the university. You become a university student and everything, so they are not taking full responsibility of you. It's not and it's also a longer period in US. US mostly they go by the transcripts and other things, but most of the time that also happens if you have a good GRE score and all. I don't think that becomes a big problem.
So can we?
So I have two questions, both of which are kind of interrelated. So, from your experience, I would like to hear how important is for a person to maintain a balance between research and teaching. That's number one. And how or else what should one do like to maintain that balance, like to be good in both? And number two, how can common man access the current research, mathematical research going on, or what does the mathematical community have to do to make sure that the current mathematical research is available to the common man in common man's language or something like that? Is it really important, or at least if it is important, what should one do to try to achieve it?
I will not answer your second question.
No, you go and read Hardy's apology.
Yeah.
I'm incapable of answering your
Exactly.
second question, and so I'm sorry I'll not answer your second question, but your first question is a very interesting question. What is the kind of research teaching balance that one should have? Until very recently, I've always made it a point to, this institute, as you know, all of us generally offer one course per semester. Until very recently, I was offering one mandatory course that the department asks me to offer, and I will offer one more elective course. I've always found that immediately after teaching a class, when I come to my office, my mind is ready to work for another 1 hour or 1.5 hours, or sometimes even 2 hours. And therefore, the reason I choose to teach more is because it also helps me. It's a very selfish motive. Maybe it helps all of us in a different in a different way. But then I've always found it helpful to me, and therefore that's exactly how I go about it. But then this is a very individual specific thing as well, in the sense that there could be people to whom, if you want to teach for 60 minutes or 90 minutes, as is the case with our timetables here, then they prepare for another 60 or 90 minutes sometimes. That's a disaster. For me, when I have to teach for 60 or 90 minutes, I have more often prepared. The preparation time for me is more often around 15 or 20 minutes. That's how much time I sit down to kind of write down my own lecture notes to kind of give a 60 or a 90-minute lecture. But again, as I said, this is a very individual specific thing. But there is always enjoyment in class, in the sense that you write down certain things, thinking in a particular fashion, and then there is definitely one student in the audience who asks you a completely, who throws a googly at you. You never thought of that kind of an explanation or that kind of a narration to the story that you're kind of developing. And then you need to kind of quickly hit it off as well, right? You cannot leave it there, and therefore you need to now think on your feet and take that question, understand what the implications are, and be able to kind of convince the other person that this is what it is. Believe me, this aspect of faculty members actually kind of explaining to you when a question is posed to them is more often done at the moment. And that is exactly how your mind expands when you think about things. This is a very important aspect for researchers to do mathematics, and therefore in that sense it has always helped me. Anything else, guys?
Yeah. I can add something. I would like to add something.
Please go ahead.
Yes, please.
So one thing I would say that most of us should, and some people may not want to teach and they don't like teaching, and perhaps such people are people who always remember everything. Suppose you can remember everything all the time, all of your subjects, then perhaps you don't need to teach, and perhaps they don't feel the need to teach. But if you are like most of the people who forget most of the things after 6 months or 1 year or something like that, then teaching the number of times you repeat it stays, it becomes a very natural second hand thing. So in that sense, this teaching does help you a lot. Every time you teach, you see it in a different way, and it helps your understanding, it builds. So I would say teaching in that sense is very fruitful, and it is very satisfying and fruitful.
But we have a second
What
question.
was the second question? I actually forgot. Can you tell me? I think I had something in the second question, but I forgot the question.
Like, is it really needed or to explain the current mathematical research to the common man, and for the research to reach them in their own terms? Like,
If it can be done, that would be great. But doing this,
so what we have to do to achieve that?
this requires special talent, right? I mean, you cannot just arbitrarily. There should be people who can understand all of this mathematics, not only understand that mathematics, but willing to spend time to just explain it to and not do. So that might be their only job. So I don't know where is this. I always post on my Facebook wall about this. There are these authors who write about this. What is this site? So there are people who convey the present research to try to convey it to the common person. And so this, if you have the ability, then that is another thing that one can take up. I mean, it should be our job to convey it to everybody, and then people can appreciate it. But it is
For
not
that
always
matter,
easy.
What my feeling is, any state-of-the-art research, it's very difficult to convey it completely to the common man. So what people are also giving in other subjects or other areas is also overall view. And I think overall view in mathematics, what one can give is only how you are connecting, how you are generalizing, and where it can, what insights it is giving to you. So that is the only thing. And what he said, if you have read those Quanta magazine articles, you will see that yes, there are people, but of course that needs a different kind of talent. I would be happy if a few of you show that talent.
Because it is great.
But not everybody will have it. Not everybody will have it. So that is also true.
So it is like getting a PhD in mathematics and now not pursuing mathematics but writing about mathematics, making
Probably
it up.
it is still easier.
Like for example, you might have heard recently he was knighted, I think, Simon Singh. So people like that.
Yeah.
So there are people who bring the mathematics to the common audience. And this is, of course, if somebody can do it, great, but it's very difficult.
Some more questions on the audience?
Good evening, ma'am. Good evening, sirs. My doubt is in the area of industry. So, if we take industries like, say, aerospace or aeronautical, these kind of fields, isn't there a very strong competition between math graduates or, say, physics graduates with engineering graduates? How is that affecting the job opportunities of math graduates? Or
I can also say.
No, you say first.
No, you say. Our moderator asked you to.
And of course, you both can speak, but
Yeah.
one of you can.
Yeah.
Yeah, absolutely there is no, you cannot feel that it's a competition. Yes, certainly there is a opponent when you go for an interview, right? So depends on the job profile, right? Everything depends on the job profile. If he is looking for something, the engineer who can really design something, he will prefer the aerospace guy. Otherwise, if he is really looking for some kind of development, software, R&D, or doing some simulations, or developing some algorithms, or doing some numerical analysis, something, definitely you will give the preference to maths. There is no, you cannot compare. That depends on the job profile.
Yes.
That's what my precise answer.
Viji, want to add?
Yeah. So I want to add that a little differently from how he put it. So if the job is about, say, financial finance, or like working in hedge funds, or say Wall Street, or say computer science, things like this, then I would say it will be a mathematician that will prefer. This is just from my experience. As I said, many of my friends who were, many who did PhD and many who didn't finish, they're all in this high profile jobs. And I'm talking about jobs that highly paid. So there somehow mathematics they prefer. Where you may not be using any of this in the job, you might be just using your computer skills, but when they want people in, the door is open more to mathematicians than anybody else, at least in this kind of jobs. And that is what I wanted to add. Of course, there are other jobs as aerospace industry.
Yeah, I
that might be
agree.
slightly different. That has different requirements, and so it depends. I don't know. But by the way, the aerospace, the airspace capital, the air capital of the world is Wichita, Kansas, and this is where most of the airspace industries are. Boeing, Raytheon, Cessna, all of these are in Wichita, Kansas, and I know there that of course they choose aerospace engineers, other type of engineers, but they also prefer a lot of mathematicians. And this, at least I know.
Just to add a small thing about, because even in India, if you see the organization called NAL, that's the National Aerospace Laboratory in Bangalore. NAL has an applied math division, and the people working there are mathematicians. And let me tell you that they can do a much better CFD simulation than engineers, because we do understand the PDEs, partial differential equations, better than them. And we know what they represent and how things can go wrong, and how while the solutions can. So that is where, so CFD is definitely an area where the mathematicians will have an upper hand over the engineers. So there is nothing like a competition. It depends on what you are looking at. If you are looking at a design, definitely we will do. Yes.
Good evening, faculty. So, I have a small doubt. So, whatever in the final year, excuse me. So, in the final year, we definitely have to do something we'll have to do a project. So, my doubt is there are various fields in mathematics. So, now how to explore it? What are different ways to explore those fields so that we can decide in which area we want to do the project on?
Before answering any of us answering this question, may I know which year you are studying in?
MSc first year.
MSc first.
No, there are.
I just wanted to know. A level where
Now you will, as part of your program, you will do several courses. You will do courses on analysis, you will do courses on algebra, you will do courses on topology, you will do courses on differential equations, everything, right? So again, it depends on what you are interested in, on which you want to do a project. Just because you chose differential equations does not make the other fields as inferior or superior, right? Your friend could have gone to do a project in algebra, and this is just a very personal preference, right? You want to do a project in a particular field depending on what you have studied so far and what has interested you and how you want to kind of further this knowledge, and that's exactly how it goes. Just because Nayanthara is a super hot heroine today does not make Padmini of my time a bad heroine, right?
I will directly answer his question if you don't mind. Okay. So this applies, I asked you this, you will understand it from my answer why I asked you. So BSMS students, obviously whoever are interested in mathematics, they have various summer vacations. Unfortunately, few of you did not have this opportunity because of the COVID, but in normal circumstances, you can actually use your summer and winter vacations to read a particular topic and see if you are interested in it. Finally, what you should do is what interests you. What is selling in the market is not what you should do. That's what I said in the very first answer, right? So that is a different story, but that will give you an exposure. So that is for everybody, even for MSc students, you will have at least one winter vacation and one summer vacation before you get into, and probably one more winter vacation before you get into your project. And for BSMS, of course, there is more opportunities. So that is what you should do.
And there are programs that that.
Yes, not just here, everywhere. You people know that better. I don't think we have to tell them. No? There is Indian Academy of Sciences.
Even otherwise, there are programs that are conducted here.
Yes.
Viji regularly conducts AFS here. Sheetal regularly conducts some training program or MTTS here. Even if you're not a regular, if you're not a registered participant in that, you can still go there, sit down and listen to lectures. Nobody will tell you get out. So you can still sit down there and listen to all those lectures and decide for yourself what you like.
So I have a question since we are talking about opportunities. So recently we are seeing that we have fields like computational topology, where in fact we use concepts like simplicial homology and we do computations there. So my question is how we can create and let students aware about such fields, because usually algebraic topology is an advanced course than programming. Apart from that, what we can do for these kind of fields?
Well, the only thing you can do is go read about the papers.
I don't expect such a question from your generation.
No. So I can tell you. So the 1 year I was in Cleveland State University, there is an algebraic topologist. There are two people. One does exactly computational topology. You go and look at his paper, and you will see a few papers, and from there you will get. Each paper will give you 2 more or 3 more papers that you can look at and at least understand a bit of it. And this way you will go ahead and learn some things about. I don't know anybody in India who is doing computational topology, but at least Cleveland State University, I forgot his name. He was my colleague for a year, but I suddenly forgot. But he is doing computational topology, and you should look at it. And this is how you learn. But at the end of the day, of course, our department doesn't have anybody who does in computational topology.
No, but you can
always
have
you can look,
discussion
yeah.
sessions,
Yeah.
and there are so many audio-visual things which will be available these days. So obviously, you may not understand or reading. You can have a discussion sessions. So see, any new topic when you want to get aware, it cannot be done in an hour. So you have to have it some at least 4-5 hours of investment discussion, which means you will also have to have 4-5 hours of reading and you looking at those videos or whatever it is, right? So that in that sense I said, because you people, information is so easily available to you people, so it will be available somewhere. Obviously it will not be easy to understand, but that you can take help.
Yeah, like these are some fields which pretty much less
Yes,
information available. Like
No, it will be there. You
No,
will
it
be
is
able
there.
to find no, you will not have courses on it. That surely may not be there. But there will be video lectures, or in some workshop. Nowadays everybody video records and puts it on YouTube. So you will have to specifically search for it.
Lumpton is the last name.
Yes, we have.
So I'm in MSc final year. I'll be going for a PhD next year. But the word is that PhD is a very long time investment, and I will have to eventually settle on some problem. Like I have to settle on some island of mathematics. So what if I go into that? We probably don't like it midway through. I mean, what should I do then?
Anything? Should I answer that? I have something to say about this. I'm sure everybody has something to say, but I want to say something. So if you are not, if you are still confused about it, it is better to maybe wait and do a little bit more mathematics by yourself, take some time off and just do, and be a little bit sure. And then you can still end up making the correct choice. Otherwise, of course, you will end up going and doing something, and you still can later in life branch out. But this becomes a little bit more difficult, but you can still do that. So that is one.
Yeah, and I mean, as far as getting bread and butter, that may not be a big problem. Because as Viji mentioned, I will also tell you, when I was just graduating from IISc, Microsoft Research had started its branch in Bangalore just then. It was, and they had visited IISc Maths department, and they had told the students there that we are not looking for any specialization. You can be from any purest of the pure maths background. We don't care. If you are ready to adapt and learn few more things, that's what exactly he said. No, we give you 3 months, you learn. And they are so assured themselves, without me telling them or without, that we will be able to learn. And that is what you are going to anyway get from your PhD. Whether you get PhD or whether you don't like your problem or like it, I mean, that is this thing, but I think you should venture into it. If you like it, if you don't like it, you should find something else. Don't worry about that. But of course, if you are sure, if you can wait, if you can explore a little bit more, do a 1 year of internship or something, that would obviously would be much better. So, but you have to choose.
Okay, we have
Yeah.
two people raise their hands. We have more.
Okay, just to add on that, a very quick answer. It depends on your interest, right? Suppose if you are going to academics, so definitely, let's say if you want to do research, definitely you need the PhD. Let's say I'm very happy to teach and just leave. There are many colleges. And for instance, if you want to go industry, it's very different. So the guy will start from masters, the guy will start from PhD. Then completely the salary will be different, the position will be different. They are not the same. So they will be much appreciated if you have a PhD, and your positions also will be different. Okay? So the growth will be very fast if you have a PhD.
But earlier I just make a small request, since we have to respect the time constraints. I would request the audience to make your questions short and precise.
Being a student of COVID times, I'm just going to ask one thing: how internships affect your application to PhDs and postdocs? Because I haven't had any chance for any internships actually. So I want to know how.
Personally,
it
I
affects.
feel in mathematics it doesn't matter much. But of course, it gives you that exposure-wise, that is a difference. That I surely believe that it gives you exposure, because 1 year you can do in analysis, 1 year you can do in algebra, 1 year you can. So I don't think, personally I don't think, and everybody knows about this COVID times, I think people will be accommodative and consider it.
Hello sir, I have a question especially to Nagaiah sir. The question is that people with applied background, especially those who wants to complete their PhD in high computational numerical analysis, data structure, or artificial intelligence, or machine learning, something else. So what are the way out? What are the opportunities after completion of PhDs, their PhD?
So whatever the areas you mentioned, they are emerging areas. So there are a lot of opportunities. There is no doubt. If you say that if you have a PhD in machine learning, just immediate day you will get the job. And if you have a PhD in that, that's it. They will give the respect. There is no doubt. Whatever you mentioned, the areas, there are definitely enormous job opportunities.
Good evening, everyone. So, I want to know something about the application process. So, since many of the people are going to start their application.
Can you speak up?
Yeah, a little bit loudly.
Could you please tell how to write SOP or a statement of purpose, so that it will have a good impression.
I'll advise you, write, of what you want to do, rather than writing to impress, somebody. Of course, ultimately there will be a committee of people who will sit down there and who will keep, looking at all these kind of things. And believe me, they are smart enough to read through your, fashionistas that you may, include inside your essay. Therefore, and the other thing which is also very valid is, now you have done some certain courses here, which means you have this as your background. And you are interested in something, say analysis or say algebra, something, differential topology, something. And therefore, you are writing about whatever you've learned in this particular topic, and stuff like that. And then you're kind of, slightly building, and then you're seeking, hey, what, these are things that, you would like to study further, blah, 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 etc. If you suddenly start jumping gears, and then if you start writing something else, people will know that this is not genuine, right? And when people read that, it actually ends up as a bad application rather than rather than you having impressed them. And therefore, whenever I have sat down to write down all these kind of essays, I have been, believe me, not just at your age, even at our age, we all have to sit down at some points of time to write down some essays and trying to see how these essays go by. I usually call them as essay writing, and I'm happy to do those essay writings at some points of times. And you have to engage in those kind of essay writings in this fashion, that how well are you able to assimilate your thoughts of whatever you have learned to be able to convey it out in as little mathematics as possible, but as much English as possible, right? You involve very little amount of notations here and there as it is necessary, but beyond that, you should not really kind of, start writing, for every epsilon positive, blah, 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 etc. People will go mad about it. So don't do that. Your statement of purpose should be something on which you have learned all these things and you're interested in these kind of things, and then you want to kind of further your studies with these kind of things. That's about it. And most of it in English if possible, rather than in mathematics.
No, I think what he said is sufficient enough. I mean, trying to impress is not going to work. Trying to be truthful is going to work. Obviously, you can show it to somebody and improve upon the language. Those things can be done, but it has to come from you, from within. Then only it will actually, and people are very smart. They can read through.
What are the main things that you will improve?
But I think for that you should have a different session with the people who have successfully gone there, because our knowledge is long ago, whatever was happening. So I think probably you can catch 2-3 people who have got it. Yeah, and then you can have online also. You can have, no? What's the problem? Even if they are not here, you can have it online.
Yes.
People who have actually successfully gone to US or Europe in last 2-3 years, some alumni, we can give you the data.
Right.
You can have the.
Yes.
I understand it's a very important question, but I think with them it will be much easier for you to get this information from.
So I have a realization that some institute in India are now also interested to hire now applied mathematicians, or more specifically data science, or those who have computer knowledge. For example, one of my friends who has completed a PhD just now immediately got assistant professorship in our institute. So my question is, what is your take or your thought, how difficult or how would be to get a job for pure mathematics 3 years down the line, assuming that they have a reasonable qualification? What is the, I'm afraid of that, so what is your quality? I want to know. This may be related to the current government.
First of all, several of you guys have gotten this into your mind of, calling something as pure mathematics and, so I mean, if you call this as pure mathematics, is the other one impure? I mean, what is your idea? No, you see, these are very wrong terminologies. Over time, we've been kind of, using certain terminologies, but then it's probably, high time that we kind of, stop using, those kind of words of calling something pure and leaving the other to kind of fend for itself as to, what it should be called as. Now, the current government of India, as you said, has asked almost all education institutes to begin a data science program, and therefore almost every institute has begun a data science program. And when you begin a program, you of course need people to run those programs, and therefore, these are matters of time. But then, if your CV is strong enough, if you have good publications, if you kind of, if you can show that, you are a consistent performer, there should not be any problem at all in getting a position in a math department in any institute. And as all these people also mentioned, it's not just that data science departments are beginning in all institutes. It's also that there are several institutes which are also starting now. We already have 7 IISERs. We will hopefully have one IISER per state or something like that. That was the aim. All these things kind of move towards, and therefore there are several IITs that are starting up, and therefore there are umpteen number of departments of mathematics that are coming up across all these institutes as well. And any IIT will any day need, a math department. They just cannot function without a math department. Who will teach their calculus 101 and their linear algebra 101, right? And so there will be all these institutes wherein the math, you will find a position. So I don't think that should be, a cause for worry at all, right at this moment. And again, from where I stand and see, this is only going to increase. The number of institutes that are going to be started in this country it's only going to increase. If there is a small, it's not happening right at this moment. Maybe I'll use a different word. If there is a small lull at the moment, it's because COVID times, and therefore we are still waiting for all these things to kind of settle down, and then maybe we will begin newer institutes after that. But then, for the population that we are, for the demands that our population has, there will be, a lot of institutes that we need to start, and those necessities will definitely kind of fall in place by the time 3 years will pass away, go away for you to kind of come to the job market, if you're interested in that.
One more.
Hello sir, I have one question. How I can write a new thesis or a new theorem?
Oh, you don't write a new theorem usually. You don't sit down and meditate and then start writing a theorem. That's exactly not how it happens. You start working on certain things, you write down what the logical flow of expressions are, you find out certain things, and at the end of it comes a statement of the theorem. You don't start with a statement of a theorem and then start, writing out its proof.
Yeah,
that's
that is very
absolutely
way of
not.
and that's not how math happens.
That's absolutely not how it happens. Believe me, your teachers could be teaching you wrong. Every time they could be writing down a statement of the theorem and then say proof. But that's not how it's done.
Yeah, the statement comes only at the end.
Yes.
To discover.
You need to start with a set of hypotheses, right? Now, what do these hypotheses mean? What is the logical fallout of this? You will have another thing. What is the logical fallout of this? You will have another thing, right? It goes on like this. It's a process of kind of finding out what this leads you to, and whatever it leads you to, when it kind of culminates, that becomes your statement of the theorem. right?
Okay, so with that, I think we'll close the session. So we have had a wonderful session where we had panelists sharing their opinion, and then we have had a lot of Q&A. So some takeaways at the end of it, if I may summarize, we looked at the system, the PhD programs in Europe and in US, where we realized in Europe it's more of a problem-based approach. The problem is defined the very first day, whereas in the US it's a different system where you start with the courses and you have some teaching, and it's a much more longer process. And then the other thing which came up is nowadays, along with the conventional mathematics, we need to complement the knowledge of mathematics with many other fields, and some of the keywords which we heard are machine learning, artificial intelligence, data analytics, scientific computing, and so on. And even I realize things like even Wall Street interviews, they require mathematicians. So definitely there's no doubt for opportunities, and mathematicians will be in demand. And with the, again coming back to the statement where I started with the new areas emerging, we have more opportunities, and definitely it's the right thing to do. And again, the message was, if you're interested really in doing mathematics, then it's the right thing to do. That is very important. If it really interests, then it's the right thing to do, and there is nothing to worry about the opportunities. We have seen about so many opportunities, different fields, and so on. So with that, I think we close this session. I want to thank all my colleagues for their wonderful words. And I would also like to thank all the members of CMIT for arranging this and for all the hard work. And I finally thank you all for being part of this evening, and I look forward to seeing you again, and good night.